All right, so here we have a question about cos, sine, and tan in radians, where I have some standard answers that I ought to be able to, if not know, then work out. And I'm told to solve the following equation for 0 to 2 pi in terms of pi not needing a calculator. I'm going to do questions 1 and 3 first, and then 2 last, because it's not more complicated, but it's worth viewing it a little bit differently. So to solve this, if I put that there, you should be able to see it. I'm going to start with a triangle. And I know that if I've got 1s and 2s and root 3s, I'm going to have a right angle triangle that looks something like that. And there's going to be my right angle. It's not particularly well drawn, but it does the trick. And I say that triangle has a length of 2 on its hypotenuse and has a length across of 1, and therefore must have a height of, well, something squared plus 1 squared is 2 squared. That thing must be square root of 3 using Pythagoras. And that's a standard triangle we might use. Now, root 3 is going to be more than 1. Of course it is. It's 1.7 something. So in this case, I can see that if that's going to be longer, then this angle in here is going to be bigger than that angle in there. So we know that that one has to be the 30 degrees and that one has to be the 60 degrees. And 30 degrees I know is going to be pi over 6 because I've done it before, and the 60 degrees is going to be pi over 3 in radians. Remember, we're going, of course, the 180 degrees is pi radians. And if I know that's 30 and know that's 60, then I can get pi over 6 and pi over 3 quite straightforwardly. I then look at question 1 here, which says that sine of theta is root 3 over 2. Well, which of these angles do I have then? I've got root 3 over 2. Well, it's a sine. Sine means opposite over hypotenuse. So there's my hypotenuse. I want it to be opposite, which is root 3. So I'm talking about the pi over 3 bit here. So I know that theta is going to equal pi over 3. But that's not the only answer I might get. To get all the answers in the range between 0, theta, and up to 2 pi, I find the best way of doing it is simply to sketch a sine graph that looks something like that. There's going to be my theta, that's going to be sine theta, and I've got some principal values. That's going to be 0, it repeats at 2 pi, and therefore that's going to be pi. And I'm told that sine theta is root 3 over 2, which comes across around there. So I've got one answer there and one answer there. That answer is as far away from the 0 as that answer is from pi. So that answer was pi over 3. That must therefore be pi over 3 away from pi, which makes it 2 pi over 3. Now that might be a bit confusing, but read that back, play that back to yourself and it should become clear. I'm using the symmetry around the pi over 2 value to allow me to calculate that. Let me do question 3 next, simply because it's so similar to what we've already done. 3 asks for what is tan of theta. So tan theta is root 3. Sorry, it doesn't ask for what tan of theta is. It says, I know tan theta is root 3. Well, tan is opposite over hypotenuse. So look here, I've got the opposite must be the root 3 and the opposite over hypotenuse. Opposite over adjacent, I'm so sorry. Tan theta is opposite, which is the root 3 over the adjacent one. So again, I'm looking at this pi over 3. So theta, again, is going to be pi over 3. But again, that might not be the only value that is in my range between 0 and 2 pi. So I sketch a tan graph. That's going to be theta. That's going to be tan theta. And it looks something like this. It goes up at pi over 2, back up from pi over 2, and crosses there. So that's going to be my 0 value. That's going to be pi over 2. That's going to be pi. Go along there, and that's going to be 3 pi over 2, and then it's going to go up to there to be 2 pi over there. I may have put my x value a little bit small. I'm looking for tan theta is root 3, which is somewhere over here. That's one value, that's my pi over 3 value. It repeats every pi. The next one's going to be pi more than that, which is 4 pi over 3. And there's my answer. Question 2 then is only a bit more confusing, simply for the minus sign or the negative sign. That's why I'm doing it a little bit later. I'm told that cos theta is negative root 3 over 2. Now, if we ignore the negative sign for a second, I can still use this triangle perfectly well. And I've got root 3 over 2. I'm looking at cos. So cos is adjacent over hypotenuse. Got it right that time. Adjacent is going to be the root 3. 2 is going to be the hypotenuse. So I must be talking about the pi on 6 value. So it's going to be some version of pi on 6. But let's see how this works. Here's my cos graph. Looks something like this. It crosses maximally at 0, so it must be minimum at pi and maximum again at 2 pi, and repeats in the negative direction as well. And so over here I've got the 0, pi and 2 pi. I know that I'm looking at pi over 6, but I'm not looking at it being positive. I'm saying that it's negative root 3 over 2. And I handle that, if I'm not allowed to use a calculator, like this. To say if it was root 3 over 2, I would get pi over 6, which would be over here somewhere. And that would be my value. To get negative root 3 over 6, though, I would say, well, that's gone, it's just going to be down here somewhere, which is where it crosses negative root 3 over 6. These are the points I'm allowed to have. Negative root 3 over 2. So where are those points then? Well, again, using the symmetry argument, this is pi over 6 away from the 0 point. So that distance there is pi over 6. Which means, again, remembering I've got symmetry here, that distance there, that one there, and that one there must also be pi over 6. And all I'm using there is the symmetry I know about the cos graph. So there's my pi value. I've got pi and 6 below and pi over 6 above. So I'm told cos theta is negative root 3 over 2. So theta I find must be, well, pi over 6 less than pi, which is 5 pi over 6, and pi over 6 more than pi, which is 7 pi over 6. Now, the reason I did this step separately was simply for the negative sign. But broadly, all I'm doing is sketching each of these curves using the standard triangle. It could be this one. It could sometimes be the other one, which has 45-degree angles, or pi over 4s in there, which has lengths of 1, 1, and root 2. And therefore, I get 1 over root 2 for sine, 1 over root 2 for cos, and 1 for tan. But all I'm doing is using that triangle, using my knowledge of the sine, cos, and tan graphs, and where they repeat and where they reflect.